Ilya.
Before we get started, I want to talk to you a little bit about how we got here. So a year ago, we released GPT-3, which is a general purpose language model. It could basically do any language task you would ask it. So the thing that was funny for us was to see that the applications that most captured people's imaginations, the ones that most reality.
So actually, that was a quarter of company being involved in the effort. I bounced ideas with Ilya for a year, and actually even in reality for multiple years we're dreaming about models that can code. And Greg, personally, he was babysitting this model. So when we started, we created a benchmark. On our benchmark, despite the fact that GPT-3 had some rudimentary coding capability, it achieved 0% accuracy. In the meanwhile, we got to the models that can, in 27%, write entire multiple lines of code and solve our coding benchmarks. Today, we are presenting model that solves 37% of problems. But of course, these are just the raw numbers. How does it feel? You're going to see today.
And before we jump into the demos, I want to talk about how you can get access to Codex. And that's really the point of this demonstration. We want to help inspire people to see the kinds of things that Codex can do. And we know that we're actually just scratching the surface of what's possible. So we actually really need your help to really dive deep into this model. So the first announcement of the day is that starting today, the Codex model will be available in OpenAI API. So we're going to be doing a beta. Please go and sign up. Get on that wait list. We're going to go and scale up as quickly as we can and try to get this out to everyone. So the second way that you can get access to Codex is we're going to be hosting a new kind of programming competition. This will be held on Thursday at 10 a.m. Pacific. Everyone's going to get access to Codex as their teammate. It will also be a competitor on the leaderboard. So it'll be really interesting to see what it's like to work with Codex. Everyone's going to be able to play with it and be able to really experience the kinds of things we're showing you today. So please show up. It's going to be a lot of fun and I think a very unique event. So all right, let's get started with the demos.
Cool. Thank you, friends. Have fun.
All right. See you later, Wojciech. All right. Hello, Greg.
Hey, Ilya.
So you have a coding demo.
We do. So there's only one way to start a coding demo.
And that is hello world.
All right, of course.
So what you see here is that Greg is typing say hello world into the text box. Now he'll press the green play button. The model will produce the code, and then we will see its output below.
And so exactly right. So what you're seeing here is a simple interface we built on top of the Codex API. So everything you're going to see today is just using the same API everyone's going to get access to. So you could build the exact same thing. So this very simple interface, all that we do is we format the instruction to the model, and we happen to format it a little bit like a Python doc string so that it looks a little bit like a comment. The model generates code, which we then just execute. And the output is displayed here. So as a user of this kind of system, you just kind of ask the computer to do something, and it actually does it.
Well, it looks like it did a good job with hello world, but let's make it a little bit more complicated. Let's say hello world with empathy.
Say hello world with empathy. Interesting.
Yes.
All right.
It's just a slightly ambiguous instruction.
Do you know what you would say to this?
I mean, I can think of multiple things. I want to know what the model will say.
All right, let's see what happens. I think that's actually a very reasonable choice. And you can ask the model, you can modify your instructions to the model as well. So the kind of thing that you can do is you can also ask it for information that is kind of stored in a session. So now I'm going to say, instead of saying hello world with empathy, I'm going to say it with empathy. And again, the model is kind of free to make a choice of what it wants to do with that. In this case, it decided to do the same thing, which I think is a reasonable choice. It formatted the code a little bit differently. But fundamentally, if you notice, it now has to kind of back reference to the previous part of the conversation. And under the hood, this is just a single request to the Codex API that we're formatting just like you would a GPT-3 request. So it's almost like a chat session of human model, and so forth.
So it looks like the model did a satisfactory job with saying hello world with empathy, but could it say it 5 times?
Okay. Now, that's an awful lot of empathy.
I think it did not a bad job, but it's not quite exactly what I wanted. I wanted to be hello world with empathy, with each one of those things appearing on a new line.
Now, if you if you want to look at the code, you can. That's the great thing about a model like this, is it's very interpretable. And so you can actually look and see, hey, this just did print where it multiplied by 5. So you couldn't say, instead say, now instead, do it with a for loop. Which again starts to be a lot of back referencing. But there we go. Is that what you wanted?
It also did what I wanted as a byproduct, in addition to doing it with the for loop. So I'd say it's not a bad start for a Hello World demo.
Yes.
But I think we can go further.
All right.
We should say exponentially more Hello Worlds by making it. We should make a web page.
We've got to make a web page if we really want to broadcast our message of Hello World to the world. So first of all, make a web page that says, let's say our message, and save it to a file.
Ooh, well,
yeah,
curious what it will do.
Tricky, taking a little bit of a risk here.
It worked.
There we go. So if you notice, if you can see the code, it's actually writing Python that then emits some HTML. And that's, again, one of the powers of this model, is it's a single model that's proficient in over a dozen programming languages. And that means it can kind of just seamlessly figure out, okay, I'm supposed to be doing HTML here, or if you want to translate from one language to another, it's quite good at that. And I think this shows you why you really want all of that capability in a single model.
Okay, so is that all we need for a web page?
Well, we should probably let people see the web page.
Seems like a good idea.
All right, so let's start a Python web server to serve that page. Let's give that a try.
It looks like pretty complicated specialized code.
Yes, so let's actually take a look. So we have web server running on port 8000. So we'll take a look. Oops, localhost 8000, excuse me. And there we go. Hello world with empathy.
Oh, I would say it's a success.
I think it's a success, yes. So this is the first time we've ever generated this particular message, so we actually didn't know what it was going to say. So you know that this particular web page was in fact generated just now on the fly for all you viewers out there.
I think that was nice to say hello world with a web page, but we should go further even still.
I think we should. And so, first of all, I do want to point out that this particular example of writing a Python web server is something I've done 2 dozen times, and I still never remember how to do it. Because between Python 2 and Python 3, the exact structure of the modules changed, that you have to create this handler object, you pass it to a TCP server, that you pass the address here and a port, and oh yeah, your address can be an empty string if you want, and then you do serve forever, and it's complicated. And this kind of stuff is not the fun part of programming, right? The fun part of programming, I'd say programming is kind of 2 things. One is understand the problem, and that includes talking to your users, that includes thinking super hard about it and decomposing it into smaller pieces. This is the really cognitive aspects of building something. And then there's a second piece, which is map a small piece of functionality to code, right? Whether it's an existing library, an existing function, whether it's in your own code base or out there in the world. And that second part is where this model really shines. I think it's better than I am at it, because it really has seen the whole universe of how people use code. You should think of it as a model that's, GPT was trained on all the text out there. This model's been trained on all the text and all the public code. So it really, I think, accelerates me as a programmer and takes away the boring stuff so I can focus on the fun ones.
Okay, so that is a working web page that we've got. But wouldn't it be nice if we could send lots of emails with Hello World to everyone who is listening to us on the live stream?
Yes. So here's a moment for everyone to participate. So if you would like to receive an email as part of this demo from Codex, I think that we should be posting a link to sign up into the chat now. It should also be displayed on the screen. So please go ahead and sign up, and we'll give you a moment to do that.
And while we are waiting for you to sign up, I want to point out how insane it is that what we are showing to you works at all. It is fundamentally impossible to build such a system except by training a large neural network to do really good code autocomplete. That's all we did. It is really simple conceptually, though perhaps not in practice, to just set up a large neural network, which is a large digital brain, which has a mathematically sound learning procedure. And that part can be understood, and it is relatively simple. And then you make it work. You make the neural network big. You train it on code autocomplete. And by being good enough at code autocomplete, we get the capabilities that you see here. It actually reads all the letters, all the words that we are giving it. It chews and digests them inside of its neural activations, inside of its neurons. and then it emits the code that we see. And because the autocomplete is so accurate, the code actually runs, and it runs correctly.
So now, let's show you how to hook Codex up to sending email. So we're going to be using the MailChimp API in order to do this. And Codex, again, has seen all the public code out there, but I want it to use my MailChimp account, and maybe I have a particular way that I want to call the API. So it's very easy to give Codex new capabilities, almost the same way that you explain to a programmer how to use a new method. You can do the same thing for Codex. And so I want to show you the only magic that's going on here is that we have this plugin where on the left is instructions for humans, and we can take a look at the actual code that is supposed to be installed on our system. It's just a very simple wrapper around the MailChimp API where I plugged in the API key already. And now we can simply take this documentation written in very readable form and paste it to the model.
So literally just those 3 lines of text is enough for the model to understand how to use the API.
Exactly. But before we send the message, what actual message should we send to people?
I mean, there should obviously be a hello world, as well as something truly useful, like the price of Bitcoin.
That sounds extremely useful. So we'll ask the model to look up the current Bitcoin price.
Let's see if it works.
All right, so it seems to have done something. And by the way, this particular API, I guess, is used enough out there in public code that the model felt it was worth its while to memorize exactly how it works. And now let's actually send the email blast. Now send everyone an email telling them A, hello world, and B, the current Bitcoin price. So we'll leave it a little bit up to the model to decide exactly how it wants to format that email.
Yeah, I'm curious what message it will choose.
Let's see what happens. All right.
Oh, looks like a very sensible message.
Indeed. So now it's calling the MailChimp API. So let's give it a moment. Spinner is still spinning.
Yeah. So it will probably, oh.
There we go.
That's a lot of emails.
Yeah, so we're sending 1,472 emails. It may take a little bit of time for these to deliver. Again, at this point, Codex has done its job. At this point, we've made the call to MailChimp. MailChimp is queuing these emails up on its servers as we speak. But as you receive the emails, please post in Twitch chat so everyone knows that they were received.
So I feel like it was a pretty satisfactory Hello World demo.
I think this is the world's most advanced Hello World demo.
And while 1,472 lucky recipients are waiting for the email, it's time for us to move to our next stage.
I think so.
Let us build a game.
All right, so we've shown building sort of very simple functionality, right? So that it's kind of single shot, it required a little bit of back referencing, but mostly it's you ask for a particular thing you want done right away, and maybe it involves doing some complicated import of a particular API and use it in a specific way. But what we want to show now is building up a more complex program, actually, sort of building something that spans many lines of code.
That's right. And the game I have in mind is one where a person will be trying to dodge a boulder.
All right, well, let's give that a try. So first of all, I'm going to look up a silhouette of a person. I figure we should probably not use a real image of a person for this because they're going to get squashed by a boulder.
That is a very wise choice. And what you see here is something very similar to the previous demo, where Greg is typing the instruction to the text box, then he presses play. The model does its neural magic and produces code, and now we get this oversized person on the page.
Yep. And I want to point out, so the only difference here, as far as the output is concerned, is this is outputting JavaScript as opposed to Python. It's actually the same model under the hood. So the only piece of magic we're not showing you right now is that we provide a little bit of context to the model. In the case of Python, we have just one example of following an instruction in Python. In the case of JavaScript, we have like 2 examples of doing it. And from there, the model latches on and just continues and continues.
Yeah, so I feel like it was a good first step. But what I would really like is for the person to be a lot smaller and for it to be controllable with the left and right arrow keys.
Great. And we also just got a report that the emails have started rolling in, so I think that's a success for MailChimp and for Codex, so I think that's great. So let's see how big we want to make the person, maybe 100 pixels. Does that seem about right?
Let's find out.
All right, let's give that a try. And actually what I'm going to also do is I just want to show people the full prompt that's being sent so that you can really see what's going on without any magic. So I just opened up the Chrome Inspector. We have a completions endpoint, and you can actually just scroll to the post message, and you can look at the entire bit of the prompt. And let me show you what that looks like, expand it out.
And to just explain what you're seeing here, the way this neural network works is that it's a really, really good pattern completion system that happens to work on patterns in code. It's like the world's best yes and improv actor whose domain happens to be code rather than improv.
Exactly. And so we simply provide it with this context of, oh, you're supposed to follow some instructions. And then the model realizes my job is to latch onto instructions. Okay, so let's get back to building. So we've got the person's 100 pixels. Will look pretty good?
I think so.
All right. Now, what do you want me to happen next? What do you want to happen next?
So I want it to be at a reasonable position at the bottom of the space of the screen and to be controllable with arrows.
All right. Well, let's do that. So first, let's set its position to, let's say, 500 pixels down and 400 pixels from the left.
Seems reasonable as far as I can tell.
All right. Let's see what happens. All right. Perfect. And now make it controllable with the left and right arrow keys. Now this is a pretty high level instruction. You know exactly what's supposed to happen when you push left and what's supposed to happen when you push right. You know, the model really has to infer what's going on in here, and it can't look at the screen. The model only has access to all of this text over here. And so from that alone, it has to infer what to do. But let's see if it worked.
Let's see, I'm curious myself. The code looks reasonable. Okay. It's quite good, but this looks like something I don't quite like. I don't want it to be able to get out of the screen like this.
All right, you found the problem.
Yes.
But it is alive, which I think is pretty good. But let's see if we can fix that problem. So constantly check if the person is off screen and put it back on the screen if so. So again, pretty high level. It's possible that the model won't quite know what we're asking for, but let's give it a try.
Okay,
Go ahead.
Let's test it. Okay, this side looks pretty good to me.
It's pretty good.
What about the other side? Let's see what's happening there. Okay, so that looks good too, except that you see this flickering scroll bar at the bottom.
That is no good. Well, fortunately, you can just say disable scroll bars. By the way, I actually don't know how to do this in JavaScript.
Does the model know?
Well,
let's
find
test.
out.
The model does know.
There we go. So phase one complete. The person is movable.
So there is a suggestion from Twitch to see if we can make it move upwards if you press spacebar.
All right, well, let's give it a try. So also make the person move upwards if you press spacebar. Let's give that a try. All right, you think it's going to work?
Let's find out. Oh!
And there we go.
That is nice. We need to make it also move downwards.
Oh, no. Okay, and...
So make it move downwards if you press the down arrow key.
So we now have this nice flying person.
Let's see. Okay, so now we have given it full,
okay.
all directional control.
Good. All right, perfect. So we now have this very nice game where the person can go anywhere with very unintuitive usage of a spacebar.
That's
but,
right.
You know, if you want to modify this, please feel free to try it at home. One of the great things about this playground is that it's very easy to export these commands. You know, you can almost think of this text as a new kind of source code, and people can modify it and fork it. So I think we're going to see lots and lots of games appear once people start playing with Codex.
Okay, so a moving person is quite nice, but we need to get a boulder that we'll be dodging.
All right, so let's search for an image of a boulder.
This one, definitely.
This boulder. All right, that's a very nice boulder.
I could not agree more.
I would not want to be that person, having to run away from this.
Okay, so once again, we just request for the boulder to appear, and it appears. I hope it will appear.
Oh, it does appear.
An oversized boulder.
Massive boulder.
Let's make it smaller.
All right, how many pixels?
Can you just ask it to be small?
Oh, that's a great point. Make it small.
Okay, this is too small. Can you ask it to be 4 times as large?
Let's give it a try. That's actually interesting. So it actually used a style.transform. Now, you might want to do it that way. If you want to do it a different way, you can also just say, set the width to be 4x larger. And the great thing about JavaScript, all of this JavaScript is just running directly in your browser. And so we actually have all of this playground set up so that if you don't like an instruction, you can just delete it. If you want to modify it, you can always just edit it, and then you can edit the code directly.
Yeah. So I like the size of this boulder.
Perfect.
But now I want it to fall down.
Okay.
And then when it hits the ground, I want it to reappear from the top again, somewhere else.
Now, the thing about Codex is that, again, coding is two things. It's deeply understanding a problem, figuring out how to chunk it up into smaller pieces, and it is secondly mapping a small chunk of problem statement to code. And Codex really excels at that first part. The first part, if you ask for too much at once, it won't succeed. And so let's actually give it a try just to say, now fall from the sky and wrap around.
Okay, I wonder if it will work. Let's find
Yeah,
out.
so this is going to require doing a lot of things. So in fact, if you notice, all that it did is it just did the first part of saying, you know what, I got to get it absolutely positioned. I put it in a particular location. It didn't do the second part. And so when Codex fails like this, the kind of thing you can do is you can just try again. And I think that, again, like one really nice thing about doing this in JavaScript is there's no punishment for getting it wrong. Right? That you have a system that's very stateless that you can just re-execute and try again. Your iteration cycle can be just truly immense. And that for me has been kind of the most exciting part about working with Codex is that it just kind of means that you get to just think about what you want and you spend less time of like, okay, now I need to go to Stack Overflow and figure out how, whatever property it is to disable the scroll bars, which I have already forgotten. But let's now try breaking down this instruction into smaller pieces. So first, I think Codex had a good point that we should first position it let's set its position to the top of the screen at a random horizontal location.
Hopefully that's a simpler instruction that it could do.
Seems pretty good.
And it did it.
Yep, and if we want to verify it's actually random, we can just kind of re-execute this code multiple times. It seems pretty random to me. Now have it fall from the sky and wrap around. Let's give this a try. So again, still a lot going on in this instruction, so it may not work.
The code is it's moving, it's going down.
Moving. Okay, we got something. We got some signs of life,
Is it going back?
And
yes.
There we go.
All right.
Very nice.
This is very nice indeed.
It is alive. All right, great. So I think in order to put a capstone on this game, we just need to...
Indeed, there's no game if you can't lose.
Sad to say, but we do need to implement that loss condition. So first, define what happens when you lose. Clear the screen and show a message saying you got squashed.
It should be an encouraging message, ideally.
Okay, well, so I just kicked this one off. Let's make it encouraging.
Okay.
So now modify that function. Now rewrite that function to also include some words of encouragement.
Excellent. I'm also curious what words of encouragement the model will choose.
So you can do it. So that's pretty good. And so the only thing is that the way that this actually was implemented is implemented as a key down listener. And what we really want is we want a function that gets called when you lose. So we can get rid of both of these, and we could try this one more time.
And so how would you make it different?
So you can say, define a function. So make a function that gets called.
Okay, let's see if it works. Oh, it is a function.
It is called you lose. And now rewrite that function to include words of encouragement. All right, let's see what happens here. And sure enough, it makes a new
Try
function.
again.
All right, let's see what happens. Now we actually have to wire this function up. So when the person and the boulder overlap at all, so constantly check. If the person and the boulder overlap at all, and if so, you lose. So I'm not even going to say explicitly call that function. Just, it's got to figure out that that's what we want. So we'll see if that happened. Ilya,
Okay.
do you want to do the honors?
Definitely.
Oh man. All right, moment of truth here. Moment of truth.
Success.
You got squashed, and a very encouraging message to try again. I think that's very good life advice from Codex right there.
Okay. I feel like it was a nice game that we built in a small number of minutes.
I think so. So we have one more thing to show you. And that with this demo, we want to help expand your mind to the possibilities that Codex can really offer.
And indeed, one of the things that we showed you in the Hello World demo is that it's very easy to teach the Codex model to use whatever API you want. API doesn't know. And conveniently, all your favorite software comes with an API.
In fact, I used to work at a company whose entire job is to build an API. APIs are out there that these days the world is really programmable. And Codex is able to hook into those APIs on your behalf. And so that the kind of end-to-end functionality that I think starts to be unlocked is that you talk to your computer and it actually does what you ask.
All right, let's see how it works.
All right, so here we have my iPad with just vanilla Microsoft Word installed on it. There's one little secret within it that we'll get to in a moment. But it turns out that Microsoft Word, like many pieces of software, has an API. In fact, it has a JavaScript API. And hey, we built a model that is pretty good at JavaScript.
Quite convenient.
Very convenient. So all we did is that we took this API reference and we formatted it for Codex. And so, we kind of trimmed it down. It's not the whole implementation of the whole API, but it's enough to make a very interesting proof of concept. And so let me show you the kinds of things you can do. So here is a poem that was actually one of my favorite poems as a child.
Really?
Oh, yeah. It's called the Jabberwocky. It's very fun. So I'm going to paste it into Microsoft Word. And, oh, shoot, let me get rid of these leading spaces before we start. Sorry, I should have done this.
Greg, this will take forever.
Hold on. You know what? Fortunately, with the Codex add-in, I don't have to delete them. Delete all initial spaces.
And it worked.
It did work.
The initial spaces are gone, but all the other spaces are still there.
Still there.
And just like before, the instruction at the top was turned into code, which was then run by Microsoft Word.
Exactly. And so we're just using the standard Microsoft Word API here. So they provide a functionality for you to get your little sidebar that we show here. And we just basically reuse the exact same code that we'd written for those other demos. And so all that's going on here is that we use the built-in speech recognizer. So we didn't write that. So if it has transcription errors, we take no responsibility for it. But then we send whatever request is put here to the API, and it generates actual code in the Microsoft Word API.
And what you see here is a taste of the future. As the model gets really good, as the neural network gets really good at turning instructions to correct API calls, it will become possible to do more and more sophisticated things with your software just by telling it what to do.
And I think this is the biggest contrast with GPT-3, like the biggest step on top of GPT-3 in my mind. And this wasn't obvious to us going in, but I think it's kind of emerged from what we've built. GPT-3 is a system that you talk to, and it talks back to you. So the only impact it has is in your mind. With Codex, you talk to it, it generates code, which means it can actually manipulate or it can actually act in the computer world on your behalf. And I think that that's a really powerful thing, that you actually have a system that can carry out commands on your behalf.
For example, let's do something a little bit more complicated.
Yep. So do you want to give it a try?
Yes. Now make every fifth line bold. Okay, phew. I was really worried about the speech recognition part.
Yes. Well, there we go.
Oh, a success.
A success indeed. So I think that's pretty good. And I think that what this kind of demo shows you is what today's voice assistants have really been lacking. That I think that what you really need is you need a system that has the kind of GPT world understanding, so it can flexibly sort of interpolate between different languages and can really understand the intent that you're putting forth.
And while we are very happy with the neural network that we're showing you today, which is a better code model than the one we had previously, it is still only just a step. The neural networks, the code neural networks that you'll have in the future will be far better than this. So this is only the beginning of an exciting future.
And so that's the end of our demos. We're really excited that you were able to join us. And so just to review, today we showed you the latest generation of the Codex model. It's available in OpenAI's API starting today, so please sign up on the beta list. If you want to be able to play with Codex in the context of a pretty awesome new kind of programming competition, that will be Thursday, 10 a.m.